Unit 4 Study Guide, question number 13. Amelia works for 6 hours and earns $48. The graph shows the relationship between the number of hours Amelia works, x, so right there they're telling you the x-axis is the number of hours she works, and the total amount she earns, which is the y values, or the y-axis. And the question is, which point represents the number of dollars Amelia works per hour? When we say this, per hour, we mean per 1 hour. So what they're really asking you for is which of these ordered pairs represents the unit rate, or gives us the unit rate. You could try to read it if you know where to look for it, or you could take any point on this line where you can clearly read the information, or you could start with even the unit rate, the rate that they gave you. You could start with that and say that it is $48. Again, the dollars tend to be on top. That they are on top because that is the dependent variable, and she earns that in 6 hours. You're wanting to know, what does she really earn in 1 hour? And then we'll have to think about which ordered pair it is. So we would be dividing by 6 to get this to become 1 hour. Divide the top by 6. 48 divided by 6 goes exactly 8 times. So it's $8 for 1 hour. You could have chosen a different point on here. You could have chosen this point. When she works 2 hours, she gets paid $16. And so if you would divide by 2 on both of those, you would find the exact same thing, that in 1 hour she gets paid $8. I'm just trying to show you that you can choose any of these points where you can clearly read the x-coordinate and the y-coordinate and use those to find your unit rate, because that's what we're really wanting to know, is which point on here represents how much she makes in 1 hour, her unit rate. Well, when she is getting paid $8, follow that line across and down. And really, you don't even have to do that. You know it right here. It is always the y-coordinate over the x-coordinate. So we want our x-coordinate to be 1, our y-coordinate to be 8, and that is answer D. Okay, and again, yes, you could have read it from the graph, but if that line were slanted different, you might not really know if that's where the 1 would intersect with the 8 and give you that as the correct answer. So it is better to go back and figure out the unit rate and then put down what you know about the unit rate being the y-coordinate when x is 1. Alright, that's always true in a proportional relationship. When x is 1, y is the unit rate. Always. Question 14. Reuben put an empty cup underneath a leaking faucet. After 2.5 hours, Reuben had collected 3/4 of a cup of water. What is the rate in cups per hour? Again, cups per 1 hour at which the water is leaking from the faucet. You want the unit rate. So what you know right now is that, and they are telling you here, it needs to be cups per hour. So that means we need to put the cups on top and we need to put the hours on the bottom, and that makes sense. Time is normally the independent variable. So in this problem, 2.5 hours is the time that we know, and in that time, 3/4 of a cup of water is And so we need to make this into 1 hour. And we want to know how many cups that will be in 1 hour. We're dealing with fractions here. We need to change this into an improper fraction. So this is going to be 2 times 2 is 4, plus the 1. It is 5 halves of an hour, 5 over 2 hours, 3/4 of a cup. To make this become 1 hour, you're going to divide by 5 halves. Do the same to the top. Divide by 5 halves, or 5 over 2, however you want to say it. Go off to the side and do your work. 3/4 divided by 5 halves. Be careful of your order. Okay, don't get these switched around, otherwise it's possible to get the wrong answer here. So it's 3/4. You don't really divide with fractions, you multiply by the reciprocal, so this becomes 3/4 times the thing that you're dividing by. That becomes the reciprocal, 2/5, or keep dot flip, or keep change flip, however you want to remember it, so long as you're doing it right every time. Now that it's multiplying, you can reduce before you multiply. 4 and 2 can both be divided by 2. Again, it has to be one number in the numerator and one number in the denominator that can both be divided by the same thing, and it must be when you're multiplying. No, you can't do reducing when it's set up as dividing. So divide both of these by 2, this becomes a 1. 2 divided by 2 is 1. 4 divided by 2 is 2. Multiply numerator times numerator. 3 times 1 is 3. Denominator times denominator. 2 times 5 is 10. That is our unit rate. It is 3/10 of a cup per hour, which, lucky for us, is answer C.